I will provide an overview of the presentation I recently delivered at a general seminar with Galileo Sky Company. During the session, I will cover key points and insights that were shared with the audience. In general, we will discuss the structure of projects, the application of equipment, the usage of algorithms that we apply, the usage of equipment, and accordingly, the elements related to software and other relevant aspects. We will discuss the methods of control that we use, and if needed, you can ask questions regarding the topic at hand. The main task is to organize the solutions that we make. That is, it is an organization of comprehensive accounting of fuel movement throughout the chain, beginning from, for instance, fuel acceptance at central warehouses, fuel transportation between warehouses, and the use of fuel tankers. In accordance with the guidelines, the refueling process involves using fuel cards for refueling equipment, fuel trucks, and refueling columns. And in addition, the connection of level gauges in tanks is important for organizing control, especially in fuel storage facilities. The basic positions of the terminal that we use are either terminals of the 7X series, which are equipped with a memory card. The 7-hub series includes terminals. The Iridium baseball block enables two-way communication, allowing control of satellite communication trackers. This advancement has made it possible to manage satellite communication trackers using the Iridium baseball block. This is a basic automation module. It is positioned at EFL 6.0 and functions as a scoreboard. The device utilizes electronic technology to provide precise control over pouring. In theory, it also has the capability to support automatic control in practice, equipped with a built-in card reader. Or you can customize it and use, for example, a reader of a different standard, for example, a MyFAR reader, instead of a pocket. Just use a stick and one-touch shipping technology. When utilizing algorithms, interaction occurs solely on port 45, although there is a configurable discrete pulse output. This output can generate 110 or 100 pulses per liter, allowing for connectivity in any location. All configurations are performed via the keyboard. In addition to pulse outputs, the module also transmits a cumulative total counter, which the operator has the ability to view on the screen. When working with limits, it is possible to display either one or another set of limits on the screen for better visualization. Furthermore, we also possess algorithms commonly referred to as interface control for the management of refueling columns. This includes the columns NARA, TAPAS, SEVER. There are some other models where column control is done via ZT 2.0 protocol. That is the simplest connection. Literally, there is a power supply, a plastic card reader, a tracker, two wiring. It turns out to be 4.5. The port of the column is connected, and we have full control over the refueling column. This enables us to read the cumulative total counter from the brain of the column with complete accuracy. There are two options available on the screen. NARA, with a built-in keyboard, or TAPAS, which is simplified and lacks keyboards. It is designed for pouring and can pour to full capacity. There are alternative options available for automation based on budget, as well as automation based on the EFD indicator that can be considered. Under it, a separate algorithm has also been developed, which allows you to work in the same mode, for example, one touch. So we presented the card, the counter automatically reset to 0. If there is a limit, 0 is displayed on the screen. When we began delivering fuel, also through the 45th port, it is possible, of course, to read 100, 110 grams through impulses. And with the transfer of the total counter. From the point of view, let's say, of the EFD indicator, now I will show separately various options for configuration in order to understand how it can be applied. Just a moment. Here we can observe the EFD indicator, and here are the available options for the pictures drawn. This is an affordable option for automation, pouring just up to the brim without precise pouring. What is visible? Power supply reader and indicator for EFD. Options of counters with a valve, in addition to a control unit for the possibility of backup shipment and control of the valve. Here we see options with a PPO counter. Here is an option for automation with an AGM counter, or an option for automation, for example, using a reliable high-precision volumeter. There are multiple ways to automate the PPO counter. Using microsense sensors, do a DD25 counter with DO14 sensor, or integrating remote controls for old mechanical columns, NARA. These options provide flexibility and convenience for automating the counter and reading data from the columns either remotely or directly. The EFD indicator is commonly utilized for a wide range of configuration options available. The same EFL 5.0 module, it can also be applied in all these variants, plus the use of modules with precise pouring, so that we, the client, have the opportunity to easily verify the equipment, verify the meters, as it uses a two-circuit valve. We have collected a total of 10 liters, precisely 10 liters, which allows for easy calibration of the equipment. Let's proceed further. We have explored multiple options to automate digital columns via interface connection, ensuring improved efficiency and convenience for users. Next is a range of modules for various tasks, either EFL 6.0, what I showed you EFL 7.0 with built-in USS, or based on the EFD EFL 4.0.2 indicator, or it turns out to be a fuel module based on EFL 6.0, the most reliable version EFL 5.0. Firstly, it's convenient that the tracker is inside. There's a toggle switch inside, a bypass for hard opening of the valve. And what a budget model of the EFD02 indicator. Let's simply take a walk like this at present. It's a great opportunity to explore its features and functionality. At 6.0, it is clear how it is used from EFL 7.0. In this particular case, we observe an example where the arrow indicator is unscrewed, and the counter is conveniently placed on top of it without any complicated procedures. Accordingly, in difficult places, sometimes when the problem is somewhere else, the module itself is placed accordingly. This is an option for automation. In addition, EFL 5.0 is the most reliable option, designed for outdoor placement, exceeding expectations. Accordingly, any equipment options can be immediately connected to it. The tracker is inside. Different options can be implemented to automate fuel tankers or refueling columns based on this module, effectively streamlining operations and meeting specific requirements. As an illustration, let me present to you the recently converted NARA refueling column, which happens to be an older one, just to give you an idea. There was a NARA gas station, old. At the bottom, the MSF25 valve was installed on the outlet, and the revolution sensor was installed on top, and then the EFL5 module was hung, and we got automation of the old mechanic refueling column in this version. The old one remained, but the module is already connected to the new version EFL 4.0.2 based on the EFD indicator. But everything is hidden inside. There are certain features for placing this panel on refueling columns inside dispatchers, where there are a lot of various electrical interferences. There is an issue that needs to be addressed. It is necessary to position the EFD indicator in a metal case in order to eliminate electromagnetic interference, which can lead to overload during operation and affect its performance. Equipment may experience malfunctions due to this issue with equipment, which can result in operational disruptions and decreased efficiency. We have successfully surpassed these positions. Let's continue moving forward and make further progress. Same thing, EFL 4.0, 5.0, 6.0, 7.0, EFD indicator, various options. The fuel filling columns are equipped with a wide variety of options and choices for customers to choose from. Now I'll visit the website to better understand the situation. There's an extra website. Here, retail prices are already posted on the equipment, which can be communicated to customers. You have already recommended discounts for these prices that are available for sale. Now, let's also consider the ruler as part of the deal we are discussing. The initial choice for a high-speed node. This is a fascinating solution that permits to organize 5 modes of operation for the client. The first is the fuel acceptance from tankers into a container with an air compartment. In this scenario, a gas separator is being employed. The fuel is being refueled by the refueler through the lock located on the upper right side. If there is such a need additionally, here we have already installed the MSF25 valve, so it is possible to refuel the equipment with precise filling. The refueling capacity of fuel tankers is estimated to be around 380 liters per minute, providing a rapid and efficient fueling process. Pump with a power of 7.5 kilowatts. Here we use EFL 5.0 for precise pouring. Well, and accordingly, capacitors are connected to us. Here we see 2 pipes, so that it is possible to pump out into the tanks, pump from them. If needed, if it's right there the screen pipe is, it's even possible to pump between bones for neutralization with counting. The gas separator is crucial as it eliminates foam and air, making it an essential component in the process. Therefore, any chance of winding the counter is ruled out, ensuring consistently accurate and reliable readings at all times. This is our biggest component. This is a variation of a node that does not have a pump. Let's head to the gas station. Different things happen based on the client's preferences, so we choose accordingly. Because there are choices for 100 liters, 180 liters, and 250 liters, there are columns for dispensing oil. There are various alternatives available for a horizontal EFL box. Now let's take a moment to review a few pictures and illustrations to better understand. Fuel dispensers. To provide an illustration, let's consider a horizontal node and examine the different options available for its application and utilization. Applications were present on fuel tankers or under containers respectively to ensure safety and compliance with regulations. Here we see the use of capacity, and accordingly, horizontal type columns are used for shipping organization by cards at 220 volts. There are the same columns available for options at either 12 or 24 volts. For use, let's say, shipments simply from any barrels, and mobile containers, for instance, which provide flexibility and convenience. Let's move on. There are vertical columns, but there is a wide range. Everything is selected depending on the task. Now, when we take budget options into consideration, these are the cubes that are utilized. Here is an option, let's say a cube without a pump based on a volumeter. This compact one either goes 936 or is obtained at 220, already built-in relay, or a contactor for controlling an external pump. In this particular case, for instance, we find ourselves present here. At this very moment I am here, and behold, this is the picture in question. Here we see using on a fuel tanker. So here there is no pump, so they just put a box, so everything is ready, packed. In principle, some of these modules are utilized for such solutions, thus they are more cost effective. There are multiple options and voltage choices available. Additionally, there are non-keyboard economic options, as well as the utilization of fueling columns like TAPAS or NARA, which are also converted for organizational purposes. During the card issuance process, there are various options available to meet the specific requirements of 380 volts in a customized manner. We have taken into consideration the equipment that you have. One of the notable features that sets us apart is our utilization of advanced gas separators. They can be used in various tasks. Let's take a look at the catalog separately now. We have a range of calibration stations. Accordingly, there are 4 available options: vertical, end, small, or medium option to choose from. The available choices for using gas dividers enable the complete exclusion of air counting and foam counting, ensuring accurate measurements. If we utilize this version of the EST03 station, which has a filling capacity of 106 grams, it weighs 161 grams. The gas separators can also be utilized on fuel tankers, for instance, in scenarios where there is an abundance of foam or when foam occurs due to an increase in engine speed. Another application is to prevent air from being pumped through the counter on the fuel tanker, so to speak. Let's move ahead. We have explored options for diverse career stations that we still offer and continue to make available to our valued customers. We have separate 0.1 standard EM Marine readers with an external antenna, which we use at the refueling column. When the reader is placed inside, the pocket is pulled outwards, that is, with a 45-degree and van wire output. There are options for inexpensive readers 0.2 and 0.4. This is either EM Marine or MIFERA standard. So we took a close look at this picture. In terms of equipment, we thoroughly covered every possible aspect. In case you have any inquiries or uncertainties, please don't hesitate to ask. Once clarified, we will proceed to examine the situation from a software standpoint. Hello, I have a query pertaining to the equipment. It transpires that the first module which you presented happens to be the smallest one. Interestingly, this module is crucial for the station that is situated in this particular location. So the module which EFD indicator showed. So interestingly, as it turns out, he has the capability to offer it to the client if he happens to have a column without a keyboard. Listen up, this EFD is incredibly universal. You can practically install it on just about anything. He has the advantage of having an accumulative total counter. If USS is connected, one of the features is direction control. He possesses a switch, which allows for switching between inputting 5 or 12 volts as a power supply, or USS, or sensor O or USS, or impulse generator. It is also feasible to establish a connection with some read counters there. In other words, he is somewhat prepared for any situation. That is why they essentially depicted here that it can be utilized for any combination of automation tasks, making it a versatile tool. An economical and budget-friendly option for automation, offering seamless data retrieval on port 45 with ease and efficiency. So, approximately speaking, will it transmit data on the amount of fuel that has been refueled and so on? When using the algorithm, for instance, if you bring the card close, it can reset to 0 automatically, or by pressing the reset button, it will show. Here is an essential fragment. If we, for instance, connect the counter directly to the tracker, not only will we have interference on one channel, the second moment, the driver, depending on the angle from which he looks at the meter, will observe different readings on the arrows, which may vary based on the viewing perspective. And if he rewrites only from the PPO counter onto paper, when this paper reaches the accounting department and the operator generates a report in the monitoring system, the numbers will be different. With the implementation of EFD indicators, we are able to effectively control and limit our deviations to a maximum of 1 liter per day. In other words, we ensure the primary aligns with the report in the monitoring system. Without this crucial step, we end up with a chaotic mess. That's it. Plus, a very important fragment. When using the indicator, the operator in the morning looks at the readings of the total counter. At the end of the day, by pressing the button, the individual rewrites and personally observes the exact amount of fuel issued for the shift, promptly recording it on paper for self-control and monitoring purposes. The human factor is excluded due to these errors, as what happens otherwise is uncertain. The driver makes an error by failing to manage the total amount for the day on the totalizer. Afterwards, the driver submits this report and creates 7 monitoring tasks to inspect other numbers. What actions are they performing? They commence addressing you. Why doesn't it function? And you commence to discern it. In order to exclude this device is employed to minimize any errors of the operator, fueler, or fueling station when compiling primary documentation, thereby ensuring accuracy and efficiency in the process. Are there any further questions or inquiries regarding the equipment that need to be addressed before we can proceed to discussing the software? If I am not satisfied, I will switch to an alternative option in order to find a better solution. We have developed a cutting-edge cloud software solution, which we proudly refer to as our flagship product. This is a cloud-based solution designed specifically for industries to enhance existing monitoring systems and improve operational efficiency. Here's what I showed you, let's say, Vialon, Fortelecom, Omnicom, Eleglonsoft. So, as of today, our solution is additionally integrated with these platforms. I will now show you how this happens. The Galileo tracker is being set up, and the Galileo tracker, respectively, operates on two servers simultaneously. One server functions as your primary server, which is the monitoring server, and the second server is established directly by our team. Currently, I am starting a company to demonstrate the minimum wage. It appears that the user has the option to choose and enable a company from their list of available companies. Active list of companies, company, Antarex company. Next, accordingly, I see here I have the refueling column is currently connected and online, operating with diesel fuel for refueling purposes. Within the access objects, users are granted the opportunity to easily create personalized plastic cards for their specific needs. To add a card, simply give a name, enter a number, remove the type, and press the plus sign. It is automatically added to the list and automatically programmed on the tracker system for convenience. If we need to block or unblock a card, we can click on the lock. Within 50 seconds, regardless of the number of trackers, the access cards are automatically blocked or unblocked. This process is quick and efficient, ensuring that our cards are secure. It's a convenient feature that saves us time and provides peace of mind. Next, we have the opportunity to set limits here. That is, we can, for example, specify a limit on a plastic card, for example, specify the resettable limit. Suppose it's on a daily, weekly, or monthly basis. The system will constantly monitor the shipment to this specific card. Additionally, in the case of using multiple trackers, the system provides seamless synchronization of limits between different terminals, ensuring efficient tracking and management of shipments. Furthermore, we have a particular section, such as the user monitor, in our possession. We already see, here I observe for today, how the fuel distribution in terms of volume was taking place. And here we can see right away what I was talking to you about, an accumulative total counter. Let's select a longer period of time now. Here, accordingly, we observe, let's assume, the output. And here, accordingly, we need to work with this, our cumulative total counter, throughout the output. Let's take into account one more point. All right, now I will choose another company to work with. So, in the event that we decide to utilize the API, I will now demonstrate how we can establish a connection between an account and the monitoring system. Let's assume, for instance, that Violon has been properly configured. As a result, within the balance management section, we will have the ability to effectively control and manage the fuel supply within the tank for optimal efficiency. Here we see, accordingly, with Violon by login and password, the schedule for the tank is pulled out, and thus we get the opportunity not only to receive information about issuance immediately, but also to control how this fuel got into the tank. And accordingly, if necessary, the operator can analyze what and how, what deviations are related to. Up until now, our organization has been actively involved in the support and maintenance of 4 different satellite monitoring systems. Let's delve deeper into this topic. In terms of limitations, we have considered the option of implementing restrictions using BROS. However, it's important to note that there are also balance-based limits that operate on a different principle. What is this? Here I am, let's say, I chose the company Anyag. I choose access objects, right? A fragment of significant importance. Maps clearly register under specific products. Even if we go in now and take a look here at the client site, there are various refueling columns registered. These columns indicate the type of fuel being used by the client, providing valuable information. When I check the plastic list, I find cards for diesel fuel. These cards have unlimited availability, which is a great advantage for users like me. And now I switch, for example, to gasoline. And accordingly, we see a completely different list of plastic cards which is designed for gasoline. This is done so that if we specify these cards as accessible, it would not be possible to get fuel with a gasoline card, for example, or to get gasoline with diesel, so that these situations do not occur. At this point, we are able to observe the precise quantity of fuel that remains on the balance located on the card. Now let's examine how the accrual and write-off system functions and operates within the given context. I am returning to the balance management section. What observations can we make in that particular section? When a plastic card is displayed, we can observe that it is divided into multiple columns, all of which are clearly visible on the display. Accrued, issued, and current balance on the card. Here I am. For example, now I'm getting a plastic card. What is visible? At this point, we can observe a completed balance, indicating that a total of 200 liters of fuel were charged. In this situation, we can see that the user receives a certain amount and gradually reduces the balance over time. Thus, here the technologies are limited, like in a bank. We have charged, and accordingly, when the fuel runs out, it is necessary again for someone to charge the fuel. And in the variant of resettable limit, which I showed, that is, for a day, a week, a month, we credited once, and accordingly either once a week or once a day or once a month the limit is reset and starts again. So in this manner, you have the choice to utilize either one of the limiting options or utilize both simultaneously. That is, for example, I can credit 3 tons to the card, but specify that no more than 100 liters per day. As a result, the system will automatically control the process, adjusting the weight accordingly. So, we have already discussed the limits, and now let's finally discuss the issue of capacitance control. So, let's choose this company. For example, let's suppose the data from August, and what are we going to watch now? We have a designated area for GSM warehouses, which is regulated by specific documentation. There is an opportunity to submit inventory documents to enter initial balances for accurate record keeping. There is a chance of generating waybills for transportation. If, for instance, fuel tankers receive fuel, there is an automated process, it turns out, for generating receipts based on capacity readings. I demonstrate that is, in the substance, what it truly is. Therefore, I choose to proceed without the use of fuel as it aligns with my intentions and beliefs. Now we are directly in a specific, let's say, monitor, which simply displays information on the screen about current balances or simply about capacities. If NPP sensor or string sensors are used respectively, it is possible to connect sensors that input not only temperature but also density information. Here we see weight and level in centimeters. Next, now I'm clicking on the checkboxes for the nodes, and accordingly, we will already receive information about the movement of fuel. That is, we practically get information for the period in the form of initial balance, how much fuel came according to the waybill, how much fuel went according to the counter, and 2 balances. One residue is obtained from the level sensor and the other is already calculated. This is inventory plus incoming minus outgoing. We monitor the usage through counters and we already have control over this. For instance, we can see that there is an accumulated shortage of 224 liters during this specific period. Here we can also see this information in a slightly different manner. I am preparing a fuel movement report for a specific period, and we essentially receive a reconciling daily statement where neutralization is conducted daily at the warehouse. We analyze our inventory for cumulative deviations, such as surpluses or shortages, to ensure accuracy. This process is carried out almost every day. In this version, we observe the statement. Here we somewhat see the results, and it started. On the 16th, an arrival occurred. The fuel slightly increased and then decreased for unknown reasons. Here we witness the almost daily movement and control of fuel, respectively, managing the process to ensure the absence of any significant ones. So if we accordingly, either there will be a problem with the arrival, that is a fuel shortage, or we, for example, have a fueling column incorrectly calibrated. Accordingly, these figures will start moving immediately in one direction or another, allowing the client to make a decision. Thus, in this context, these indications are essentially equivalent to accounting indications. If you have any inquiries about this part, please don't hesitate to ask. I think that everything is already quite clear and there shouldn't be any confusion.
Unfortunately, we don't have any specific questions or concerns regarding this particular part. We have thoroughly reviewed it, and everything seems to be in order. If you have any further inquiries or need additional information, please don't hesitate to let us know. Thank you. Here are a few additional questions that I would like to inquire about. Could you please provide answers to these as well? Feel free to ask questions. In terms of software, I have already presented the fundamental aspects, so please don't hesitate to inquire further. When we place orders for speakers with your company, we consistently face problems. One major concern is the volume specification, like the claim of 240 liters. We would appreciate clarification on the basis for this measurement to ensure accuracy and avoid any discrepancies in our orders. And how does it correlate with work in any way? Are you referring to these numerical values specifically? Where can I obtain deviations from? Well, take a look at this. It states here that there is a fuel deduction of 180 with a pipe diameter of 40 and 240 with a pipe diameter of 50. All right, I comprehend. Let's take a different approach to pouring. We should think creatively and explore alternative methods. By brainstorming and developing a unique strategy, we can optimize outcomes and enhance the overall pouring process. So now I will open the Petranka. So specifically this node, which is high speed, that is, we have now switched to a pump of 7.5 kilowatt, and as a result, we specifically received a flow rate of 383 liters per minute, which is quite impressive. These are verified. Accordingly, there is a flow through the MSF valve, here probably about 120 liters per minute, through a 25 pipe, well, because the pressure is high. Filling speed is primarily determined by pump power, as different pumps can achieve varying filling accuracy. The speed of filling depends on the pump used and its power. Position evaluated. Here is a pure representation of the Exotron. It was claimed to have 240 liters, but it gave us 100 liters less. Well, they just didn't want to sign an accent on the work. I understood, look. Although there is a minimum amount of oscillation, there are no kilometers anywhere. Look, we have already closed this question. Look, we resolved this issue by replacing the existing pump with a more powerful one. In the first version, we use a pump on 3.5 kilovolts. Now we have switched to a 7.5 kilovolt pump and we have obtained normal pressure. The flow rate is 380 liters per minute. We have already confirmed this. Additionally, we have made the necessary additions here based on the specific requests of the client. About talking? Presenting a typical vertical EFL box with a 400-watt engine. The power is specified in watts, with no mention of kilowatts. This standard configuration ensures efficient performance and reliable operation. We just installed the client with a declared speed of 180 liters, and in the end we achieved the same speed of 60 liters. It's unlikely that it's 60 liters, as there is a pump capable of handling a flow rate of 400 liters per minute. Yes, okay, understatement true, but because the gun is big, it didn't fit in the tanks, but when it comes to your gun, which you sent, there were only 70.
The only thing is, there is indeed a cistern there. It's located underground. Perhaps, of course, it is challenging for him to pull her, but still 180, 170, more than what is expected. But the capacity is calculated, the column is calculated for the ground, of course, more capacity. But that means to say, the tank is above ground, but it is at the bottom. It stands below. Actually underground, so most likely quite a distance between the column and the capacity, correct? Big, maybe distance. We can't even get you to give us approximate numbers. And I don't know, maybe you shouldn't write this when you're testing 180 liters under lab conditions because, well, it's very difficult for the client afterwards. You can't explain why it's not 170 but 70. Well, then, most likely there are some peculiarities here. So, firstly, probably there is a long tube at the bottom, maybe narrowed, and accordingly you got such an effect. Because we have 180, this is in the standard version. If there is a ground capacity, you can easily connect even 5 meters there. So some even pour more. On the contrary, even 180, they even pour over 200. So in these challenging conditions, specifically the technical requirements, she is unable to simply pump up the pressure because the machine lacks enough power to lift the fuel from the lower area. 400 watts. Do you have an engine there? No, there is a kilowatt one, I think. There's a KW one, I think. There's a KW 181 is KW, 65 ones are 400W.
This drop is too high, making it difficult to lift the fuel. It falls short of the expected word count by 3 words.
We have this effect. A common query. They often inquire about the optimal spot to hang the hose for convenience. Do you have any earphones? There is some kind of device. Something has to be invented. Attach something to the side of the box.
There are pockets. Kindly specify the pockets to the manager in the designated order of preference.
Oh, so you mean I need to mention this additionally? Yes? Yes. Additionally to speak. Yes, there are pockets. There are pockets. Can you please tell me the cost of this item? I'm interested in knowing the price. So, after the dialogue, I will simply send you a price list. There are pockets there, I'll tell you. All right. At the moment, I am unable to recall from memory. No, there is also a list of prices available. Yes, there should be pockets. Let's see, are there any additional questions that you have? No, there are no more questions. Then, in principle, I will record the video, and after the dialogue, I will try to save it for you and send it. Thank you for your attention. If you have any questions, I'm always available. Goodbye.